Good morning, everyone, and welcome to the July edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. I am Sandra Rain, the Regional Climatologist from the Southeast Regional Climate Center, and I will be giving a climate overview and a tropical update. Our speakers today are Jeff Dober from the Southeast River Forecast Center, who will provide a water resources overview, Pam Knox from the University of Georgia, who will give an agricultural impact update, and Michael Pilecki from the National Centers for Environmental Information, who will talk about the new climate normals. We thank them all for joining us. Just a reminder to type your questions and comments in the question box at any time, and they will be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to this recording. Okay, let's talk about the climate. Temperatures were near average across the Southeast region for the past 30 days. However, the Washington Dulles station in Washington, D.C. did observe its fourth warmest June on record. Precipitation varied across the region for the past 30 days, which is typical during the summertime. The areas that saw above average precipitation were the areas that had the greatest impacts from the tropical systems and some thunderstorms. Speaking of tropical storms, we started off this hurricane season with tropical storms Anna and Bill. Tropical storm Anna formed on May 22nd, making 2021 the 7th year in a row to have a named storm prior to the official start of the Atlantic hurricane season on June 1st. Fortunately, both of these storms stayed out to sea. I'm skipping over to Tropical Storm Danny, which made landfall on June 28th in South Carolina. This is the first named storm to make landfall in South Carolina in the month of June since Hurricane 1 in 1867. Danny produced rainfall amounts of about 3 to 5 inches across South Carolina and Georgia, but fortunately, it dissipated quickly. Backtracking to Tropical Storm Claudette, which was named after crossing the shoreline into Louisiana on June 19th. As it tracked northeastward, it was downgraded to a tropical depression, but then re-intensified to a tropical storm again on June 21st over North Carolina. Claudette impacted the southeast region with heavy rainfall. Tuscaloosa Airport reported 8.16 inches of rain on June 19th, making it the wettest day ever on record. Flash flooding was reported in Alabama, Georgia, and the panhandle of Florida. Severe weather was also observed with Claudette. Pensacola Airport reported a wind gust of 81 miles per hour due to thunderstorms associated with Claudette. A few tornadoes were also reported. An EF2 tornado occurred in Escambia County, Alabama, with winds of 127 miles per hour. Emergency management reported up to 20 injuries with this tornado. Unfortunately, there was a total of 14 fatalities with Tropical Storm Claudette, including 10 from car accidents, 2 from fallen trees, and 2 from flooding. More recently, Elsa was named a tropical storm on July 1st, making it the earliest 5th named storm on record, surpassing Tropical Storm Edward, which was named on July 6th of last year. On July 2nd, Elsa became a Category 1 hurricane. And as it moved its way into the Gulf of Mexico, it made landfall in Taylor County, Florida as a tropical storm on July 7th. Elsa brought heavy rains, storm surge, gusty winds, and even tornadoes to the southeast region. Unfortunately, one person was killed in Jacksonville, Florida, when a tree fell, and 17 people were injured at a Georgia military base due to an EF2 tornado. With such an active start to the season, it looks as if it has calmed down, with no tropical cyclones expected over the next 5 days. Moving on to the El Nino outlook, On July 8th, the Climate Prediction Center issued a La Niña watch, although neutral conditions are favored from August to October. La Niña will have the potential to emerge sometime during the September to November timeframe, with a 66% chance of it continuing from November to January. Although many models suggest neutral conditions to continue through winter, there is a historical tendency for a second winter of La Niña to follow the first. Moving on to the U.S. Drought Monitor, severe drought still persists in the western part of the United States, with many wildfires occurring as well. Some of these wildfires may affect our air quality over the Southeast region. Closer to home, however, we see that the tropical systems have eliminated the severe drought that was near the Carolinas and has also helped reduce some of the drought in Puerto Rico. Now we have just a little area of moderate drought at the Virginia-North Carolina border, with some abnormally dry conditions persisting through North Carolina and Virginia. However, drought removal is likely over the next month. As we get into the next 3 months, the Climate Prediction Center has a high probability of warmer than normal temperatures and a probability of wetter than normal conditions. But looking over the 6 to 10 day outlook for July 14th through 18th, we see the probability of warmer than normal conditions in Virginia and North Carolina, with the neutral conditions for the rest of the Southeast, and some probability of below average precipitation for the North Carolina, South Carolina, and Georgia coastlines as well. For the rest of this week, we'll probably see some more summertime thunderstorms, hit and miss, but other than that, it looks to be less active as far as tropical systems. So just to sum up, near average temperatures were seen for most of the Southeast region. Precipitation has been variable, which is typical for our summertime. We saw tropical storms Anna, Bill, Claudette, and Danny, and Hurricane Elsa. The Climate Prediction Center has issued a La Niña watch, and so neutral conditions are still favored throughout the summer. Abnormally dry conditions still persist in Virginia and the Carolinas, and Puerto Rico as well, with a little area of moderate drought. We should see warmer temperatures for Virginia and North Carolina through the next few days, and the next 3 months will likely be warmer and wet. Now I'm going to pass it on over to Jeff Dober with the Water Resources Update.
Okay, thank you, Sandra. And here is our late summer flood outlook, and we'll start off looking at the stream flows across the Southeast, and we see that we are experiencing, as far as the 28-day average stream flow, experiencing above normal to well above normal stream flow across most of Alabama, parts of eastern Mississippi, and also parts of the Florida Peninsula and the Florida Panhandle. We're also seeing above normal stream flow across parts of eastern North Carolina, and this is associated with the 2 tropical storms that Sandra was talking about. That was Claudette in late June, mid to late June, and then the recent Hurricane Elsa that went up across the Florida Peninsula into the Carolinas. And so you can see on the right there the track record for the 28-day average stream flow duration hydrograph, where we were falling pretty rapidly since the springtime, though continued to be in the normal range with the tropical systems. Overall, the Southeast has bumped back up into that well above normal range for the region. Go on to the next slide, and we'll break it down by state just to give you a picture here. And in Alabama, again, Claudette helped bring stream flow across the state to that well above normal range. But for Georgia, it's still in the normal range. and as well as Florida, making a pretty good swing there from just below normal to now we're in the above normal range. So, and again, that's the recent rainfall, the recent convective activity, as well as Elsa. We go to the next slide here, and we'll go into the Carolinas, and you can see North Carolina, South Carolina, and Virginia pretty much treading right in that normal range, which is a good thing. We'll go on to the next slide here, and we'll show you, this is the current river conditions as of yesterday. And as we pointed out, we've got high stream flows, and with Elsa moving across the central Florida area, especially the Tampa area, it has a lot of small headwater rivers. We did get some minor and moderate flooding, and we have minor to moderate flooding ongoing in parts of the Suwannee River watershed, in particular the Santa Fe watershed there in North Florida. We do have one minor flooding ongoing or predicted up there in eastern North Carolina. And we'll go on to the next slide. And flooding is not out of the, or not completely out of the norm for this time of year. On average, the Southeast, when we look at this time of year relative to the entire time of year, over the entire year, this is sort of a quieter time for the Southeast in general. We're in week 28 here, and you can see typically we don't see a lot of activity, and typically we don't see a lot of tropical activity. So we probably are a little bit above normal as far as typical flooding for this time of year. But if we go next slide, I'll show you when we talk about the Florida group, especially the Florida Peninsula, this is their true flood season. This is their convective wet season, and tropical activity picks up. So week 28 here for the Florida group, you can see flooding in general ramps up, especially in that Tampa and the areas that have the high stream flow and flooding ongoing right now. And this lasts until sometime in September. And this is, again, the convective season leading into the tropical season. And if we go to the next slide, here is our late summer flood outlook for July, August, and September. And we're continuing to think we'll have typical flooding. The next couple of, even though we are very wet and there is an inherent sort of vulnerability to flooding, especially going into the tropical season, because we really don't peak till September. We're still thinking typical flooding for most of the Southeast. The next few weeks relatively look wet, but looks like more scattered showers and thunderstorms and no large scale organized rainfall. Probably the biggest threat will be potential for small stream headwater flooding and flash flooding as we go, which is typical during the months of July into early August. Now we go into the last slide here, and this is our summary slide. And so overall, we're seeing stream flows above normal across Alabama, most of Florida, and parts of the Carolinas. And this is because of the recent tropical activity. The summer outlook calls for typical river flooding, really from July to September. And this is fairly minimal, isolated with this time of year, with the exception of the Florida Peninsula, where we pointed out their flood climatology generally shows an increase in magnitude, and the number of river floods goes up with the tropical and wet season. But as far as flooding, the real threat is going to be flash flooding and headwater flooding through the late summer across the Southeast, which is fairly typical. And tropical systems, again, will also dictate the flood threat into the autumn. All we need is one large system, which those happen, especially you get into August and September, and that can create a very high risk of river flooding during that time. And that's the water summary overall. As far as drought and water resource issues, there's really a minimal threat heading into the late warm season. So that is a good thing. The negative on that side is that above normal stream flows, again, creates that inherent vulnerability to flooding during the late summer. And that's all I had. I will go ahead and pass it on to our next speaker.
All right, well, thank you, Jeff. Appreciate that. I'm going to talk for just a few minutes about agricultural impacts. And I'm Pam Knox, the director of the UGA Weather Network and an agricultural climatologist. So I want to first just recap for a minute on the first slide, the temperature and precipitation. Sandra already showed some of this, but it's worth looking at again, I think. Temperatures have been relatively low. The nighttime temperatures not so much, but the daytime temperatures have definitely been depressed because of the cloud cover and the humidity. And so that has kept temperatures down more than the nighttime temperatures have. And then on the left here is just another view of the precipitation for the last 30 days. And I drew on this the paths of the three tropical systems that have gone over us, Claudette and Danny, just that short track there going in from South Carolina into Georgia, and then Elsa. And you can see when you look at these that most of the rain has fallen along the track or to the right of the track, which is pretty typical of the storms, especially this time of year. Claudette gave all that rain along the Florida panhandle and then on up, and then Elsa, of course, brought all the rain to the peninsula of Florida and then eastern Georgia and then all the way up the East Coast. And so that has given us a lot of our rain this year. And so we're actually sitting very good. There's not very many negative impacts, except that there's almost too much rain in some places. So if we go on, some of the impacts that we are seeing, that the moisture and cooler temperatures have reduced the dry areas that we had earlier this season. They have improved the conditions for forage and pastures. It was early in the season, they were having issues and having to feed hay quite late, but that's all gone away now. Damp conditions have caused a lot of problems for farmers in terms of fungal diseases on vegetables and row crops, as well as pecans. And you know, it's so wet that they can't really even get into the fields to put on fungicides and other chemicals like that. So that's been an issue for them. And then when you look at the effects of the three tropical systems, they were mainly rain events. There were some high winds and severe weather reported, especially in Elsa, but also, as Sandra mentioned, in Claudette. And winds and rain really help spread disease quite a bit by splashing up spores from the soil onto the plants, and also blowing the spores from one area to another, or the insects from one area to another. So those are definitely vectors for increasing diseases on a lot of plants in agriculture. Go on to the next slide. As I mentioned, the rainfall has been an issue for hay production and preventing farmers from getting into the fields. It's also the extra rainfall has also been a problem for grape producers because they like it typically a little bit drier. It concentrates the sugar in the grapes a bit more. So that's been an issue for them as well. But other than being behind in hay cutting and the grapes and some splitting of the blueberries from too much rain, farmers, I think in general, are not complaining a whole lot. I mean, they always complain about something, but in general, I think they'd rather see a nice rainy season like this, especially one that's relatively cool compared to what we have had in previous years. And then, as I mentioned, also the heavy rains have caused some suffocation. There's so much water in the soil, there's no oxygen, and that's causing some problems for plant growth because they do need oxygen in the root zone. There's been some problems with erosion and other problems just with so much wet conditions. But there are also some issues in central North Carolina and Virginia where it has been drier. They have been missed by some of these tropical rain systems. And so they've been a little bit drier there. I don't know that it's going to continue, but that's something that is a little different than most of the rest of the Southeast. We go on. The rainfall across the region the next week. This is just from the GFS model. And the real story here is day after day of rain. I've had measurable rain in my rain gauge here in Athens for the last 6 days in a row, including over an inch last night. These are just pop-up thunderstorms. They're not very organized, but they do tend to carry water from one part of the region to the other. And that is really expected to continue for at least the next week, maybe 2 weeks. It's not an unusual pattern for the Southeast this time of year, especially if you've got plenty of soil moisture to work with. The clouds will probably keep the temperatures relatively on the cool side. It's not like we're going to be cold. It's just going to be a nice, pleasant summer season as opposed to the really hot we have some years. And as Sandra mentioned, there's no tropical storm in sight. Pretty typical for this time of year, not a lot of activity. We're going to be watching towards mid-August and later for more activity for that. We go on. Some of the other threats that we're going to be looking at, this excess moisture, of course, is going to continue. We'll see some effects of locally heavy rains, as Jeff mentioned, and potentially some erosion or some flooding from that. Will also continue to affect the fungal diseases and farmers' ability to get into the fields. The rainfall and the clouds might slow crop development slightly, but surprisingly, even though we've been cooler than usual, the solar radiation is a little bit ahead of normal. And so it's not going to cause a big impact. And as I said, the tropics, probably not going to see a whole lot of effect. You know, it's interesting because in the Southeast, up to 30% of our summer rain can come from the tropics. So we're happy to see that as long as they're well spaced and don't drop too much rain at any one spot. We go on. Okay, so here's my summary. Not too many adverse impacts from the tropical storms this year, other than lots of rain and some locally severe weather, some issues from the rain causing more diseases. Not really any signs of flash drought this year, although there have been some dry areas from time to time. Lots of disease pressure from fungal diseases and insect pests, and the tropics are expected to be relatively quiet, but the current cycle of rinse and repeat over and over again is expected to occur for at least the next week, maybe 2 weeks. So that's not going to go away. And that's all I've got. And so we'll pass it on to our guest speaker, Mike Flecky.
Thank you very much, Pam. Basically, we can go to the next slide. I think you all probably know what normals are, but I always have, as a start to my talks, this slide that basically says what normals are for us. Okay. So normals are standard 30-year averages and the statistics during those 30 years of weather observations. And what they do for us is provide a baseline for putting today's weather in context, often used by broadcast meteorologists or by the National Weather Service to indicate whether today is above or below normal, or the coming days are above or below normal in terms of temperature, or was last month wetter or drier than normal, like Pam was just talking about. They're also used for understanding today's climate for decision making, and this occurs when we need to make weather-related decisions beyond the range of dynamical forecasting. For instance, in the energy sector, what would be the typical load factors in August for the need for electricity for air conditioning, for instance, or agriculture, what would be the best seed variety for the particular climate you're located in. Construction, you might actually want to know how many rainy days would you typically have in October, because you're going to be doing a construction project during that period. You want to build that into your planning, and so forth and so on. So there are many different sectors and industries that need climate data just to give us the best characterization of what the climate is today. Next slide. So key takeaways from this little talk will be that we design climate normals to meet the needs of our user communities, and also to meet the needs of standards that are international in scope. The data that goes into the normals comes from The National Weather Service systems, especially their ASOS automated systems, their co-op observer network. We also, for the first time, are including data from SNOTEL, the USDA's snow telemetry network, and also from COCORAS, the Community Collaborative Rain, Hail, and Snow Network, for stations that have sufficient data to either estimate a normal or actually calculate a normal. So one of the things that's kind of interesting about this is that citizen science is a key to normals, because about 90% of the normals data is coming from either COCORAS or the co-op network. So you're basically looking at a tremendous input of volunteer labor here. Also, just to let you know that NCEI, the National Centers for Environmental Information, is the source of official climate normals for station locations in the US, and were used for legal purposes for many sectors. And also, we always like to remind people that 30-year normals are not simple averages. There's quite a bit of complexity to calculating the data behind the normals and the normals themselves. And also to let you know, we do have a new normals web page now, which is that link at the bottom of the page. Next slide, please. What did the new normals say? Well, we have about 15,000 station normals for precipitation, which is quite a large increase from the last time because of the addition of COCORAS. And then we also have 7,300 stations with temperature normals. We also, of course, have hourly normals, and I didn't put the numbers here, but we have more hourly normals than we've ever had before. We used to just have a couple hundred. Now we have almost 1,000 stations with normals. So it's really quite a useful data set for those people interested in other variables such as wind and clouds and other things that we can get from the hourly data. Also, what we found with the temperatures were that there was warming pretty much widespread across the US, but the north central US as a region tended to actually have less warm normals for the 91-2020 cycle than the 1981-2010 cycle, which is kind of interesting and probably related to atmospheric circulation becoming more meridional and more frequent incursions of cooler air during the winter and spring in that area. And then precipitation changes were kind of variable from month to month, but generally wetter in the southeast and in the central US. And we'll also look at some specifics regarding the southeast a little more later. Next slide. In addition to the conventional 30-year normals, we've actually created a whole set of 15-year normals for 2006 to 2020, because some of our customers, some of our economic sectors really needed climate data for the period much closer to today. And this is especially true of power sector, electricity sector, et cetera. A few other groups that really wanted normals for a period that was shorter than 30 years because of the fact climate is changing, and they wanted something close in. We had the supplemental temperature normals last time in the 81-2010 cycle, but we decided that we do a full set of normals this time around. So that's what we're providing for people as an alternative. Next. Included in the normals data set, of course, you're thinking annual, seasonal, monthly, daily temperature, precip, and snow. Basically, those are the fundamental variables for most of the normals that come from the daily data sets that we have. And then the hourly data sets also have dew point and sea level pressure and clouds and wind, things that could be useful for a variety of purposes. And then finally, we not only have the averages, but we, of course, calculate degree days. We have counts and frequencies above or below certain thresholds of temperature and above certain thresholds of precipitation. We have growing season statistics, the first frost probabilities, the last frost probabilities, the length of growing season. And then for precip, we have terciles, quartiles, quintiles, looking at the distribution of precip. Next slide. Just a little hint as to why things aren't quite as simple as a simple average. The monthly temperature data that we use is what we call homogenized. What we're doing here is, before we calculate normals, we take the time series of temperature at all the different stations and we do a pairwise comparison with surrounding stations. And sometimes you find that one station out of a group has an abrupt change or discontinuity, and that usually is caused by an artificial effect, like changing the station location in a small, footprint around an airport, for instance, or changing the instrument type, or changing even sometimes just the instrument itself. Even if the type doesn't change, you can get a discontinuity that results. This example that's given here for Dayton, Ohio, shows that this particular site has had several different discontinuities relative to its surrounding stations, and have several adjustments going back in time. And one of the things to know about homogenization is that once we identify a discontinuity, the adjustment or correction is propagated back in time, so that if we have any discontinuities found, say in the last 10 years, they were not involved in the calculation of the last set of normals, but do affect the comparison of the two time periods. And so this has been an issue that we're addressing with a new web page that's going to come out in the next few days, probably later this week or early next week. And I'll talk about that a little more at the end of the talk. Next slide. And however, that being said, that there are complications and so forth, the theoretical basis for U.S. climate normals hasn't changed, and this is the main research paper that describes that. One of the key things that's of interest to people that you may not recognize is, we provide both daily and monthly normals, and we actually take great pains to make sure that they are compatible with each other. For instance, if you take the daily normals of temperature for a month, they will average out to the monthly normal for that location. If we take the precipitation is usually calculated in month to date or year to date. If we take the month to date value, the month to date value on the last day of the month is the same as the monthly precip normal. So all these kinds of efforts to make the data consistent, high quality, and for temperature to make it homogeneous give us a different result than if you were actually taking individual time series of raw data and just doing a 30-year average. Okay, next. All right, let's go into the fun part, the actual normals here. What we have also included in our package for this year that we're working on is a new set of gridded normals too, because we have the NCLIME grid data set, which is been around for a while now. We use that for creating our climate division data or county level data or other kinds of areas, state level data. But it exists at a 5-kilometer resolution, so we can actually also do normals with these data. And so, in fact, these maps are created from those normals. We will eventually have a nice atlas, which we haven't quite finished yet, so that'll be something to look forward to in the future, but it'll have maps that look like this. But what people are mainly interested in now is what is the difference? How have the normals changed? And so next slide. This is an example of looking at an individual month and how it changed between the 1981-2010 cycle and the 1991-2020 cycle. And on the left, we have two different ways of looking at precipitation, one being in percent change and one being in inches of change. And you can see the Southeast is in the month of April has had quite a bit of change. The areas around the Appalachians and in some locations have upwards of an inch or more of precipitation change in just a single month. Percentage changes of 10 to 20%. So it's pretty large amount of change in some areas here in the Southeast. Temperature-wise, you can see that April is the month that has the largest cooling in the north central US, which is why I kind of featured this map. But you can also see that the Southeast is during this month warmer than it used to be in terms of the April temperature normals, both for minimum and maximum temperature. Next slide. But these differences vary by month, and here I want you to focus on the Southeast because it's an interesting story. You can see that in October, it's considerably warmed from the last set of normals, but in November, it's actually cooler in much of the Southeast compared to the previous set of normals, which is an interesting change, but again, related to issues like atmospheric circulation variations, frequency of tropical events, etc. And then back to December, we have a return to much warmer than previous normal set conditions across most of the country, including the Southeast. So what this would indicate to me is there's a shift in the shape of the seasonal cycle of temperature here in the Southeastern US, which is kind of interesting to see. Next slide. And here we just grabbed a handful of stations from around your region in the Southeast. And notice, unlike a lot of other cases where I give talks in other regions of the country, every single precipitation change is upward. But some of them are truly large, like in Asheville where I live, we've had an almost 4-inch increase in precipitation. In Miami, over 5-inch increase in precipitation. But most of the area, it's between 1 and 3 inches of precipitation increase for the annual precip total. And it's pretty assured that we're definitely looking at a wetter climate. And also in this case, we also have warmer, both maximum and minimum temperatures everywhere on an annual basis, usually from anywhere from 0.3 to almost a whole degree Fahrenheit. And again, it looks kind of boring, but that's the Southeast is responding in a pretty uniform way to climate change in terms of how the normal has changed from the last cycle to this cycle. Next slide. And of course, if we look at the whole lower 48, you can see the change on an annual basis is the central and eastern U.S. is wetter. The Appalachians are especially wetter. And of course, the northern part of your Southeast region is increased a little more than the Georgia, Alabama kind of area. And of course, southern Florida is back again in the wetter side of things. And also, annual mean temperature change has been quite warm here in the Southeast along the eastern coast with the Atlantic Ocean warming. you would expect Florida and the East Coast to be one of the warmer areas, and it is also on an annual basis. Next. What's interesting is, now that was comparing the two normals. If we compare 91-2020 to the 20th century average, the 100 years between 1901 to 2000, you get a slightly different picture here, which is that, yeah, it's warm everywhere, but it's slightly less warm in the kind of the western end of your southeastern region, because that area has also gotten quite a bit wetter. And so that's kind of dampened the warming signal here in that area. But look at Florida is as warming as you can get in this map. And basically that, of course, again, is because the oceans around Florida are considerably warmer, and along the East Coast too. So you can see that when you are comparing to a longer term average, you really see the effects of climate change going on here in the latest normals. And so the next two slides illustrate that even better. The next slide is the precip changes, and you can see that during the 20th century, if we look at the 30-year normals as they evolved over time, there were quite a few periods that are drier than they are today, especially, of course, periods that include the 1930s droughts and the 1950s droughts. But by the time you get to the end of the previous century, the 71-2000, you can see most of the US is wetter, and that even increases more as we go to the next two periods. However, in the latest period, you can see that we're beginning to get drier in the West again, while we have this kind of ubiquitous kind of wetting in the areas east of the Rockies. All right, next. And with temperature, it's even a more spectacular signal. Most of the country is blue there at the beginning of the 1900s, and people forget that it was actually very warm during the 30s too. So you get a pretty widespread warm signal, and then it got cool again in the mid to late part of the century, and then finally, when we get to the end of the century, you can see us just going in one direction towards warming. And so even though normals are not really a great way to look at climate change, we prefer people actually look at trends of longer term data. It does have the fingerprint of climate change, and you can see how that is affecting our climate. There are some people that say that we should not be changing the goalposts, as it were, that we should not recalculate normals so that people know that every day is above normal, and so forth and so on from a messaging standpoint. But the fact is, we need the normals to move with time, because there are so many sectors that need to know what's going on with the normals now, so they can make plans and make decisions today. But if you want to really know how climate is changing, let's look at the trends in climate separately. Okay, next slide. So a few issues that are remaining that are coming up. We are actually correcting a few stations in Alaska. We usually, and the last time we did the normals, we actually use non-homogenized data right near the coast of western and northern Alaska, because the change in sea ice has been so abrupt during this period that it kind of looks like an artificial temperature change to the coastal stations compared to the inland stations. So we tried it with homogenization, and we decided to go back to the practice of not using homogenized temperature data for the coastal station in Alaska. So we'll be releasing those changes in our actually this week, I believe, and you'll see that on our website, information about that. And also, like I said, we're going to have further documentation and explanation of the impacts of temperature homogenization when you're comparing 91 2020 to 81 2010. We've had this issue with not with the maps, because the maps we're using the same data set for both the 81 2010 and 91 2020 data set. So that's giving you a true kind of comparison between the periods. But when people took out the station data that were calculated in 2011 for the 1981-2010 period, we didn't recognize that this would cause confusion, because there's been 10 years of homogenization that's taken place between 2011 and now. So you really need to recalculate the 81-2010 normals to get a true temperature comparison between the two periods. And so we provided, or are about to provide, the monthly recalculation of the 81-2010 normals for people that want to do that comparison on a station by station basis. And that will be released in the next week to 10 days. All right, and then finally, the gridded normals you've already seen, and they're technically available somewhere on our website, which I won't mention because it's not the final location that they're going to be at. We'll do a more formal release of that later this summer, so people can use that. And we'll even have daily gridded normals that will be ready in the second quarter of next fiscal year, around March 2022. All right, next slide. So that pretty much finishes up the talk. And again, that's our new normals website. And we also have a new WMO normals website, because we are the collection point for the 1991-2020 normals from all the nations of the world. And those will be collected starting this fall and into next year. And you'll see them appear on our website next summer. And then, one link to one story, and there's other stories around. We were very happy to see climate normals maps cover about a third of the front page of the New York Times last month. It was, or in May, I should say. And it was, there's been quite a bit of interest in the new normals, and we're very happy that people have noticed the change. Okay, thanks. And that's it for my slides. Thanks.
All right, thank you, Mike. Thank you so much for that presentation, and thank you to all the presenters today. Meredith is not here today; she's on vacation. But I'd like to remind everybody that this webinar is put on in partnership with NIDIS. There will be a recap email with a link to this presentation sent to everyone. If anyone has any questions, please feel free to start typing them in the question box. And I guess we will start with some questions here. Mike, this one's for you. Can you briefly explain why NOAA calculates the normals based on a decadal cycle instead of an annual rolling 30-year cycle?
Well, we do that mainly because that is the requirement of the World Meteorological Organization, and also of our partners in the National Weather Service. The issue with doing a rolling 30-year average would be a lot of nations in the world don't have the personnel or ability to do this every year. And it is a pretty arduous task involving quite a few people to do this, and it's good to have a stable kind of setting for the conventional normals, because a lot of legal decisions are made based on that too. The other normal that we're doing, the 15-year normal, we're actually contemplating, if we have the resources, to move that along in time in a 2 to 3 year kind of cycle. So that would be updated more frequently than the the conventional normal, which will still only be updated every 10 years. But we're not sure we have the resources to do that, but we're definitely considering doing that because we'd like to have at least one option or alternative to the conventional normals that kind of moves along through time. So we are considering that. Yes, thanks.
All right. This is another one for you, Mike. With the differences maps, are they available for each month, and are they available for individual states or regions? Melissa from the South Carolina Climate Office has had a lot of questions about the changes in normals, and they're trying to create the maps in-house.
We can provide you with the data if you want to create your own map. We are in the process of doing that as part of creating an almanac, but or an atlas, I should say. But the problem is that we've had a bit of a reduction in our workforce that was working on this problem, so they're not quite available yet. If you have a specific need for the U.S. map, we can provide those to people, but we can't really create state level maps at this point. We are going to, of course, be releasing the normals data in a net CDF format, the gridded normals, I should say. So one should be able to, with proper personnel abilities, be able to take that and create your own maps as you see fit. But the one thing that I would suggest, though, is we do have our partners at the Northeast Regional Climate Center are able to have a tool that allows you to zoom in on a particular state or region and create a normals map, although not a comparison map, but a normals map using our normals gridded data. Yep.
All right, and just continuing on the questions for you, Mike. Given the comment about the difference in homogenization on the 1981, will NCI redo the comparison maps, and can you make those maps available for individual states and regions?
Well, no, the comparison maps don't have this problem because both the 81-2010 and 91-2020 periods come from the same data set that was frozen as of May 2021. So both periods on those maps have the same basis of data and same homogenization applied. So that is going to stay the same. It's individual stations that have a different 81 to 2010 temperature record now compared to the 1991-2020 record 10 years later. And so that's the one where we are providing for maximum minimum temperature for all the stations that had 81-2010 temperature normals and are still able to create 91 to 2020 temperature normals. We are now providing, or will be in the next week, the individual values for those 12 months of the year for 1981-2010 as calculated using the same data from the same February 9th, 2021 version of the data that we used for the 1991-2020 normals. So you'll be able to do that on a station by station basis, but the gridded comparison is staying the same because that already is using the same homogenized data. Okay.
All right, and then what is the size of the individual grid cells for the national grid data set?
Well, it's technically 1/24th of a degree by 1/24th of a degree, which works out mainly to about 5 kilometers. it's 4-point-something kilometers, depending on what latitude you're at. So that's the resolution.
And then have you considered buying data from automated ag weather stations to include in your normals in the future?
We, as a rule, tend not to purchase data because everything that we have in our Global Historical Climate Network data set has to be able to be rebroadcast to the general public. While the Weather Service can buy data to help with their forecasts and their verification of forecasts, that's an internal process going on. Ours is a public-facing process, so the only data that we can use are data that we can rebroadcast to the general public for free.
Okay, all right. Does anybody else have any other questions? I believe that seems to be all the questions that we have. I'd like to remind everybody that our next webinar is August 10th, where we're talking about heat risk tools for the Southeast, and Dr. Chip Conrad from the Southeast Regional Climate Center will be presenting on that. And I guess if there are no other questions, or if you do have any questions, feel free to just send us an email. We'll get back to you. Other than that, I'd like to thank everybody for joining us, and we'll see you next month. Thank you, everyone.